Hi, I'm Matt Wynne from the Cucumber Open Source Project, and this is part 4 of my BDD 101 series for ConformIQ. In this video, we're going to talk about sort of broader strategy and tools. We've got into the overview of the main 3 practices of BDD already, so we've talked about discovery, formulation, and automation. And this time, I'm going to give you a bit more of a deeper sense of how to do those 3 practices well. So now you know what they are, we're going to talk about how to do them well. Let's start with the whole overall idea of shifting left. We know that in BDD, we're practicing these 3 or 4 loops of first we figure out what the next user story is, we do some discovery, we do some formulation, we do some automation. At each of these stages, we're going to be learning more about the problem, and we may feed back and need to rework some of the stuff that we've come up with. So this emphasis on learning is really the key part of BDD and the sort of philosophy of BDD. And if you think about a typical sort of traditional software project where a lot of the testing is done at the end, we see this kind of curve where the amount that we learn, the insight that we gain about the actual problem we want to solve and the way the system is solving it and the way the programmers understand it, that insight is kind of peaking in this crescendo at the end of the project or the deliverable, or even just if you think about just a single user story. And that's really not a good pattern, right? We get surprised late in the day, people end up having to work late or miss a deadline because we'd left this learning to happen right at the end, this very risky way to proceed. What we want to do is kind of flatten the learning curve. So we front load it. We're probably going to do the same amount of learning overall, right? But it's just a question of like, where is the shape of that area of learning? We're going to have the same area under the curve, but what shape does it have? We're going to try and shift the learning to happen earlier because it's cheaper. Like we can rework ideas much more cheaply than we can rework code. So if it's possible for us to test our kind of ideas and understanding, that enables us to flow the code out of the door more efficiently. So let's talk about discovery. With that in mind, let's talk about 4 good practices for doing discovery. First of all, I want you to come from this point of view of like a childlike curiosity, right? It's very easy for us to get stuck on or fixated on all of the things that we already know about the problem space and about what we want the system to do. But actually, that's the easy bit. The hard bit is figuring out all the stuff that you don't yet know. That's where all that insight's going to come from in that curve. So really embrace that ignorance, right? Assume that there's a lot of stuff that you don't know yet about this project, about this problem, and look for that instead of getting fixated on writing down about the stuff that you do already know or talking about that. So embrace your ignorance. Secondly, if you're doing discovery sessions like we talked about, the example mapping technique for running a discovery workshop, try and do those discovery sessions in short, punchy sessions frequently, rather than saving it all up and doing it, say, every couple of weeks for a whole afternoon, right? People's attention spans just don't last that long. It's going to be quite stressful work, right? Dealing with a lot of uncertainty. So we want to try and keep our energy levels high. And so it's a much better pattern rather than trying to do it all in one big batch. Do it little and often. Really, as I said in that example mapping episode, 25 minutes should be enough to analyze a user story. If it's taking longer than that, the story's probably too big anyway. So just try and break up this work into small, punchy chunks rather than trying to do everything all at once and making the sessions really long and tiring. The other thing to remind you of is that we want to get these diverse perspectives. We want to do this discovery through conversation. It isn't good enough to have one person going off and doing the discovery, writing that down in a document or in a Jira ticket. The way we're going to get the real discovery of those unknown unknowns, embracing our ignorance, is by asking each other challenging questions and having conversations to get more understanding about the problem. So really important to embrace that 3 amigos pattern where we have at least the tester, a programmer, and a product specialist or domain expert in the conversation together to figure out what the shape of this user story really is. Finally, the whole point of discovery really is to try and maximize the amount of work not done. So it doesn't mean we're never going to do it, but it means we're not going to do it right now. We're not going to do it today. So we're always hunting for what is the core of this story? What's the smallest piece that we could build now? So always be looking for opportunities to shave off additional complexity, additional aspects of the story that don't need to be done right now, scenarios that you don't need to worry about right now, maybe whole rules that you don't need to worry about right now. Sure, you can come back to them later, but try and find the core and find a small story. So let's talk about formulation now. There's 4 good practices for formulation here and that I'm going to tell you about today. And one of them is really this idea that you don't try and do discovery and formulation at the same time. It's a pattern I've seen lots of teams do, and it's kind of really one of the reasons we came up with example mapping, is to give people a way to have that structured conversation without getting bogged down in the details of how exactly are we going to express this in Gherkin, because it's very distracting. It's kind of working at 2 different levels. So don't try and juggle both those balls at the same time. Get the discovery done, or as best you can. Sure, you might discover some more stuff when you try and formulate, but don't be trying to type in Gherkin at the keyboard while you're doing the discovery. Work with lighter weight tools like stickies on a post-it on an online whiteboard. The other thing to say about the sort of order that you do things in is to make sure that your formulation is happening before you get into the automation and the coding. We want to use BDD all the time as a way to discover what it is that we don't know yet. And writing the specifications down in a Gherkin document is going to give you that chance to say, do we really understand this yet? And you're going to be forced to think it through in another level of detail. It's almost like a simulation of writing the code. And so by doing that, you give yourselves a chance to check what your understanding is without the expense of actually writing the code. So make sure that you try your best to not only do the discovery work, but do the formulation before you write the code. Maybe not all of the formulation for all of the scenarios for a whole sprint, but certainly a couple of scenarios before you start to implement them. And then you can work back again, remembering those concentric feedback loops, right? Do a couple of scenarios of formulation, do the automation, come back and formulate another couple of scenarios. It doesn't all have to be done in batches. You can do it in sort of continuous loops. The other really good practice about formulation is to think about having the people with the most to learn write the Gherkin. A really kind of common pattern that most teams fall into is that their domain expert will write down their understanding in Gherkin and pass it over to the team. Actually, a much better way is to work in this feedback cycle where you have a conversation, and then the people who were listening in that conversation, that would be the developer and the tester, try and distill what they learned in that conversation into a Gherkin document and show it to the domain expert to check their understanding. This is a much more powerful pattern. In pair programming, we call it strong style pairing, where the person with the most to learn, the knowledge has to flow through their fingers. And by us doing that, adding that constraint, we test out quite how well everybody really understands what we're talking about. And this is a really great way, again, to embrace your ignorance and try and flush out as early as you can all of those potential misunderstandings. So this is why we draw this feedback loop here. Somebody with the most to learn will try and write the Gherkin, and then we can pass that to our domain experts as confirmation. Did we really understand everything that you needed us to understand before we go off and build this? Another common problem I see when I read people's formulated Gherkin is that we see a lot of language in the Gherkin that is describing very detailed interactions with the system, clicking on things, tapping things, swiping things, filling things in, rather than the what. So rather than talking about how the test is going to run, try to talk about what it's going to do. This leaves you with scenarios that are not only easier to read, but they're also a lot more stable. They're less brittle to changes in the detailed interactions within the system, right? If we change exactly how the withdrawal flow works in the ATM, we've still got a valid Gherkin document. We just need to change some code underneath that implements how we do the withdrawal. So those taps and so on that we've got in the imperative right-hand version would get kind of pushed down into somewhere in the code that we could still read and use if we needed to, but we're not going to be stuck with it right out there in our Gherkin, which clutters it up, makes it hard to read, and also makes it very brittle. So on the right-hand side, we see the imperative stuff, bad. On the left-hand side, we see a more declarative style, which is good. Great. Now let's talk about automation. What's some good practices for automation? I've got 4 for you again. First one is good old test-driven development. This has been around since the late 90s or the early 2000s as a sort of established practice in our industry. And this is absolutely the philosophy that BDD practitioners were coming from when this whole methodology was invented. It's what I do every day, and I recommend it to you as well. There's a lot of benefits from doing test-driven development, when you're doing this automate stage of BDD. We're kind of vague there about exactly how you're going to do your test automation versus your implementation, but I'm telling you, a really good practice is to write the test, make it fail, and then do the implementation. You get into this really nice feedback loop where you know that all of the code that you've written is only there because you have a failing test. And that means that because you have this safety net of all of these tests that can definitely tell you if anything slips loose in the code, it allows you to refactor, it allows you to tidy your code and improve its design, which necessarily has to happen over time as your software changes. And that's how you really stay agile, is by constantly refactoring the code to keep it as easy to work on as it can be. And you really can't do that without the safety net of those automated tests that were written in order to drive out the code that you can really trust. Talking of trust, never trust a test that you haven't seen fail. This is kind of the flip side of doing test-driven development, right? A lot of times if we're doing test after, building software backwards, as I call it, if we're doing test automation and we're adding a test afterwards, all we're doing is confirming that we see the behavior that we thought we'd see, but we don't know what that warning light is going to look like when it goes off. Much better is to break the software, either by not having yet implemented it because you're doing test-driven development, or at the very least, go into the working system, make a change to it so that it's now defective, and see what the test looks like when it fails. Because you really need to know now, when you're in the act of writing it, when the code's all warm and you understand it, you need to know what that test automation is going to look like when it fails. Is it going to give good feedback? Does it clearly say what's wrong and where the developer needs to go to fix it? If it doesn't, you can iterate on it and improve the label on that warning light before you move on to the next test. And this testing pyramid is a very familiar pattern to many of us from software testing, but it's really worth reiterating here, is thinking about when we're doing any kind of test automation, what is the lowest level in the system that I can connect this test to where it would still be useful? And we obviously need to integrate some parts of the system together sometimes for some tests, because the behavior that we're describing is implemented through several pieces of the system, subsystems acting together in concert. But what is the lowest level that we could test this at and it still be valid, still be hitting the right if statements in the code? Because the more layers we add between the probes of the test, the more chances there are for something to go accidentally wrong. Maybe it's a timing issue because the network's slow today, or we have to wait for our Chrome driver to be up to date with our latest version of Chrome. There's just more layers, there's more stuff to go wrong, and worse of feedback, because the tighter we can have the test pointing at the specific bits of the code where that behavior is implemented, the less places you have to go hunting when the test goes off and fails. So finally, when we're doing all of this, what we end up with is what we call living documentation, but it can be hard to maintain living documentation. You need to keep running those tests over and over to make sure that you're actually validating your living documentation. If you do that, you're going to get this benefit that you know that you've got a specification in the system that is actually live and true because you've been validating it regularly. But that's not enough on its own. You really need to publish the documentation somewhere that the whole team can read it. And that's great because it increases sort of trust in the process. You get people being able to start using it for new kinds of benefits. Like, we're thinking about adding this new feature to the system, but how does it already behave? Well, people in totally non-technical people can come in if you published it somewhere and read what the system does. I've even seen teams that use their Cucumber specifications as like API documentation for users. So good to publish it somewhere that everyone can read it. And also, if you've got stakeholders that are like legal auditors and so on, they can use the documentation as their proof of how you've tested the system and what it does. But tooling wise, like, this can be hard. So with free tools like Cucumber and Visual Studio Code, you get a really long way, right? Cucumber's amazing. You can run it on all of these different platforms, the JVM, Ruby, JavaScript. There are even Cucumbers for exotic languages like Elixir, old favorites like PHP and Perl, Python. So there's lots of ways that you can execute your Cucumber tests, but they do end up with the results just kind of staying in the developer space. You maybe see them on your CI platform, but it's hard to get those feature files like in front of stakeholders. Also kind of guidance for if you're learning how to write Gherkin and you want to get some guardrails for that. It can be pretty intimidating starting with a blank feature file. VS Code with the Cucumber plugin can give you some guidance. It can look at your existing step definitions, try and help you to not make so many mistakes and keep your Gherkin language consistent. But it's still tough with those free tools. So keeping an eye out for tooling that's going to help you to keep sort of with that bigger picture, keeping the test automation code organized, being able to see the wood for the trees, right? Be able to see how these scenarios fit together, and keep the stuff published in a place where even non-technical stakeholders are going to feel a part of it is really important. And what we're actually going to do in the next one of these videos is I'm going to talk to Alexis from the ConformIQ visualizer team, and he's going to talk about their tool and what they're doing with that, which I think is going to alleviate some of those problems I just talked about. So we'll see you next time. I've been Matt Wynne from the Cucumber Project. Thanks very much.